Hello everyone. Today we're going to be talking about polynomials. We're getting into our next unit here. So we're starting off with the language. We're going to be adding, subtracting, and multiplying polynomials today. So just to go over some language here, to review what a constant is, we do have a value that stays the same. And then I will be doing an example as well. And so for the example, I have my polynomial of 3x squared and then plus x plus 5. And that value, the only value that will stay the same here is the 5 because it's not going to be multiplied by x there. Now we have a variable. This is an unknown value. And for example, we have our variables here. So the 3x squared plus x plus 5, the x values here, these are our unknown values, the variables there. Then we have our exponents, and the exponent is a power being added to a constant or a variable. And that does say variable on there. So again, on our example here, since you guys can rewrite it, actually we'll write it down here just so you can see. So our constant or our exponent is going to be added to that variable there. It could be also added to a number, and actually the invisible variables here like are 1 and 1, so those are still exponents. Now that's different than a degree. So a degree is going to be the highest exponent. So in our example up there, the highest exponent is the 2. And again, the highest exponent in this case would be the 2. So we'd have a degree of 2. A coefficient is the number before a variable. Before a variable. So in our case, this 3 right here, the 3x squared, is our coefficient. And then we also, like if we have this plus x, remember the coefficient that's also visible is a 1 in front of that one. Then we have a term. This is a polynomial that is actually separated by an addition or subtraction sign. And I'm just going to use the addition or subtraction sign. So those are the signs that you will see that will help us separate our terms. So here in our example, if you were to see this, we'd have our 3x squared plus x. So we have one term, two terms, and then if we had the plus 5, then that is our third term. So we have 3 terms there. Now, a polynomial is made up of numbers, variables, operations, and you can have one or more of them. So we're going to be discussing a couple of those as well. So let's just write down the definition first. So again, that was made up of numbers, variables, operations, and you can have more than one term. And then factor is our last one. So to factor means to actually break down. And so we learned back in elementary school, you can also multiply. We're going to be multiplying. Back in elementary school, we were taught to take like, okay, if we have the number 12, what are all of the factors of 12? So I'm trying to figure out all of the numbers that go into 12. So we have 4 and 3. We know that we have 1 and 12, we have 6 and 2, and so on. So 4, 3, 1, 12, 2, and 6. Those are all of our factors. So if we were to multiply these numbers back, we get right back to our solution of the 12. So 4 times 3 is 12, 1 times 12 is 12, and 2 times 6 is 12. Okay, so let's move on to calculating our actual degrees here. So we're going to start naming polynomials. So I'm just going to start off with the degree down here. So let's do our degree column. We're going to start at 0 and then number this 1, 2, 3, 4, and 5 is where we're going to stop at, just for this case. That's as high as we're going to go. So then for our name using our degree, so if we see that we have a 0, this will be a constant. This will have a 0 degree. So that'll be a constant. So like that number 5 actually had a 0 degree. Yes, the exponent was a 1, but that doesn't mean that the degree is the same thing. So just to give you guys a heads up. If we have a degree of 1, so that means we have a variable, that's our degree of 1, then that means that we are going to have a linear, and again I will be showing you guys examples, so actually here, let's do it right now. So our constant is 5, and then for our linear we would have our like x plus 4. So that's what we've been graphing lately. So again, this is our linear. And then if we have 2, a degree of 2, we're going to have a quadratic. And then that means that for our example, hopefully I could squeeze these in. So I have like a 4x squared, and then minus 2x squared plus x. Okay. And then if we have a 3, that means we're going to have a cubic. And it'll look something like this. Actually, and I'm going to erase this example, you guys. So I have x plus 4 here. And I'm going to say that this was quadratic again. Sorry about that. And then we're going to have 4x squared here. Just 4x squared. And then down here, we're going to have 4x to the third minus 2x squared. Sorry, I was looking at both examples at the same time. So 2x squared plus x. That'll be our cubic one. And then we have our, so 4, a degree of 4 is actually called a quartic. And then for our example, it's going to have that highest degree of a 4. So 4 plus 5x squared. And then our last one that we're going to be dealing with is a quintic. And that's a degree of 5. So for our example there, this is going to be a little bit longer. I'm going to write it down here. So negative x to the 5th power plus 4x squared plus 2x plus 1. Okay, so now we're going to define the number of terms here. So if I just have a constant, that means we have one term. If I have an x and it's separated by a positive sign right here, and then I have a 4, we have 2 terms. So again, remember I'm separating them by the positive or the negative sign. So I just have one term here. I don't have any positives or negatives or addition and subtraction signs. I have 2 of them here, which means I have 3 terms. I only have 1 addition sign, which means I have 2 terms. And here I have 3 addition signs. So I count right before them, and I have 4 terms here. Okay, so now we're going to name this polynomial using the number of terms based off of that. So for our first one, we have a monomial. Mono means 1, and I probably can't fit this. So monomial, you guys, you spell it M-O-N-O-M-I-A-L. Okay, and then we have a binomial. Bi means 2, so we have binomial. And then we're back to a monomial again, because we only have 1. And then 3, tri, we have a trinomial. And then we have 2 again, so we're back to a binomial. And that last one, the 4, so for our 4 terms, basically we call it a polynomial of 4 terms. So anything 4 or above, we just call a polynomial. Let me actually write some of it up here. So polynomial, and you can just call it even a polynomial. I-A-L, polynomial, and we'll just say I have 4 terms. And then we'd have a polynomial of 5 terms, and so on. Okay, so go ahead and rewind this, you guys, if you did not. So I hope you were listening to me, and you can. I'm spelling some things out for you guys, and you can go from there based off of that. So again, rewind it, stop it, pause it, all that stuff. So now we're going to go over just 3 examples. So for our first example, we are going to be adding or subtracting, second example, and our third example will be multiplying. So for our first example here, I'm going to go ahead and write it out first. Okay, you guys, I'm trying to write this and squeeze it in. So we have 6m to the 4th power minus 7m squared plus 5m minus 2 plus, and this is all in parentheses again, negative 3m to the 3rd power plus m squared minus 4m, and there's a plus 1, and then close those parentheses right there. Okay? So addition means what we're just actually combining like terms. So I have a 4th degree. That's the only one I actually have, so I'm just going to rewrite that 6m to the 4th power because I have no other ones to actually combine my like terms with. You always write this in standard form, so the highest degree to the lowest. And so now we're going to go to over here because I have to the 3rd power. I don't have any other ones that are to the 3rd power, so we have a negative 3m to the 3rd power. Okay. Now I've gotten rid of that, Now I do have values that are squared. I have a negative 7m squared plus an m squared. So negative 7 plus 1 is going to be a negative 6m squared. Got rid of those 2 variables. And again, you can see I'm going from descending order, 4, 3, 2, so that means I'm on my 1s. So 5m, positive 5m, minus 4m is going to be left with just an m. And then we're down to our constants, which is the 1 and a negative 2. We're left with negative 1. So addition, we just get to combine like terms automatically. Now if we're dealing with subtraction, let's go ahead and write down that example. So sometimes, it most likely will always be in parentheses because it wants to make sure, I'm not going to use the variable s, let's use x. It will make sure that you are distributing that negative sign all the way to the entire parenthesis behind it. So let me show you what I mean by that. So at negative, we have 8x to the 6th power plus 7x and then minus 10. Okay. So what I mean by that is this negative has to get distributed to all of these things behind this. So I'm going to rewrite this term because this term does not get touched because it doesn't have a negative in front of its parenthesis. And now I'm just going to start distributing this. Negative times the positive 8x to the 6th power is a negative 8x6. Negative times the positive 7 is a negative 7x. And a negative times a negative is now a positive 10. So now I'm right back to where I was on example 1 where I can combine like terms. Again, we write it in standard form. So the highest power I have is 6 to the 6th power, so I have a negative 8 to the 6th power. Then my next one is going to be the 3x cubed. I have no other terms I can combine with until I get to here, the negative 5x and the negative 7. So I get a negative 12x, and then 10 plus 4 is 14. And that is my final solution there. And then our last example that we have today is going to be multiplying. The value that I usually always see students get confused here is that you guys want to just bring that to, say, x squared plus 4. Done. So what this actually means is I have to write out my polynomial or my binomial twice. So this answer is going to be much different than just saying x squared and then 2 to the 2nd power before. So x squared plus 4, that's not going to be the answer. So let me show you why. Now we get to distribute x times x, which is x squared. X times 2 is a 2x. Now we have to distribute this value, so 2x, 2 times x is x, 2x. 2 times 2 is 4. Then we combine like terms. Our like terms should always be in the middle value there. So our final answer should be x squared plus 4x plus 4. So we end up getting that middle term like we wouldn't have if we just distributed that 2. So again, this is the correct way of doing that, multiplying that example. All right, you guys, I will see you in class. We'll be practicing a little bit more of these, and I hope you have a good day.